Today we will continue with IR spectroscopy, and this where we will take up about mainly carbonyl groups, that is spectrum due to carbonyl group and the variations in carbonyl group due to various conjugations or some other groups. So let's start with have the great value, and these have great value. These are very important absorptions to identify any compound, and these have special significance for six-membered ring and the rings which have smaller ring size, and in which for each ring smaller size there is a decrease by 30 centimeter inverse. This we can see with the following examples. In this example, this is an open chain ketone and this is a closed chain ketone. In this there is a no difference. This again 1715 centimeter inverse, and for that also there is a 1715 centimeter inverse. But when it is 5-membered ring, in that ketone the value is increased by almost 30 centimeter inverse, and for 4-membered ring ketone, and it is around 1775 centimeter inverse. That is by decreasing the size of the ring of the ketone, the value increases by around 30 centimeter inverse. And when the carbon-carbon double bond is in conjugation with the carbonyl group, then this lowers the observed carbonyl frequency by about 60 centimeter inverse compared to that of non-conjugated carbonyl. That is, and thus there is a conjugation. So here the value is decreased by around 30. That is, it is 1685 centimeter inverse. But in this example where there is a double bond here, if it is a double bond here, then it will be a conjugated. So there's a absence of, there's only single bond, so there's a no conjugation, and in this case the value is 1750 centimeter inverse. So if the conjugation is present, the value is decreased around 30 centimeter inverse and 1685, and if there is no conjugation, then it is the 1715 centimeter inverse. So in similar way, in the carboxylic acids in which the carbonyl group is present and the OH group is also present, in that case due to C double bond O, we have a sharp signal around 10 centimeter inverse. We have already done this for C double bond O groups, and the OH stretch of carboxylic group, due to the strong hydrogen bonding, it is around 2500 to 3500 centimeter inverse. This is important to be noted down. That is, due to hydrogen bonding, the value is around 2500 to 3500, and it is a strong hydrogen bonding. So this can be further seen in the spectrum. That is, in this this is the spectrum. In this around 1710 there is a strong peak which is characteristic of a C double bond O stretch, and then around 3000 these are the for saturated carbon atoms, and now this peak is very broad. It is due to the OH stretching. So due to OH stretching, this is very broad in case of carboxylic acids. And then the aromatic compounds. In aromatic compounds we have weak CH stretch at 3030 centimeter inverse, and weak absorptions around this range 1660 to 2000 centimeter inverse, and medium intensity absorptions around 1450 to 1600 centimeter inverse. That is, these are very important, and these are indicative of the aromatic ring, and these corresponds to the weak and medium absorptions. And so in aromatic compounds, wherever aromatic compounds are present, there are in around this range weak absorption, and this around this is a medium intensity absorption. So these are the aromatic compounds. If we see its spectrum, of compound having any benzene ring and there is a acetylene group is present, so it is a phenylacetylene. In this, the absorptions are, for benzene ring there are two absorptions near 17. Here these are the two peaks due to the benzene rings, and then around 3300 it is due to the CH stretching, that is which is attached to the triple bonded carbon atom, and this is 3300, and these are due to the and these is due to C triple bond C stretching, and then these are the normal stretchings for the wherever the aromatic rings are present, that is around below 1500, and these peaks will be seen in every aromatic compounds almost. This we will see in further examples. So this is a aromatic compound again. In this aromatic compound, that is phenol, there's again these aromatic ring. Due to this there's a two peaks around 14 to 1600, that is these two peaks which are due to the aromatic CH stretchings, and then these are the due to the benzene rings, and then these are the OH, and this is strong and broad peak due to OH. This also we have already done around 3300. And then if we see another example, and that is this, and this again these are the peaks due to the benzene ring, that is double bond CH stretchings, and then this is due to the around 3000, that is saturated carbons due to, and these are the lower carbon and other stretchings. So next similarly we can see in this double bond is present in this, the slightly it is around 3000, but it will be slightly to the left, and all these are due to the benzene ring. So we can identify the compound or the functional group present in a compound by seeing these spectrums.